Namaskar and a warm welcome to this series of lecture. Myself, Dr. Praveen Kumar Sahu, belonging to Government Syama Prasad Mukherjee College, Sitapur, Chhattisgarh, India. And this is a lecture pertaining to MSc Mathematics 4th semester of Sant Gehra University, Sarguja, Ambikapur, Chhattisgarh. And the paper is 5th paper, Numerical Analysis Part 2. And the unit is 4th unit, Solution of Algebraic and Transcendental Equation. And this is my 5th lecture on this 4th unit. And the topic of this lecture is a very important topic in unit 4, Convergence Analysis. So let's start the lecture. First of all, we will see the point that we will discuss in this lecture, means outline of the lecture. In this lecture, we will define the order of convergence. Then we will see the convergence analysis of bisection method as well as Newton-Raphson method. Then we will discuss advantage and disadvantage of bisection method and Newton-Raphson method. Now, today we would like to consider the error analysis and convergence analysis of bisection method as well as Newton-Raphson method. Before we will define what we mean by order of convergence or rate of convergence. Suppose we have a numerical method like bisection method or Newton-Raphson method which generates a sequence of iterates which we denoted by x0, x1 and so on xn. So what we have a sequence xn which is a sequence of iteration and which converges to a root alpha. Means what we have been given that the equation f of x has a exact root alpha. So here xn is the nth approximation of alpha, so xn will not be equal to alpha. Now, what if we have two constant k and p such that limit tends to infinity mod of xn minus 1 minus alpha divided by mod of xn minus alpha to the power p is equal to lambda. Then we say that the given numerical method converges to the root alpha of the order p. Means what we have here, xn is the nth iteration or approximation that we have generated by using that numerical method, and xn plus 1 is the n plus 1th approximation or iteration that we have generated. And here we want to determine the difference between n plus 1th approximation minus alpha in absolute value to the pth power of nth approximation minus exact root alpha. If it is equal to and constant lambda, then we say that the given numerical method has order of convergence p, and this constant lambda is known as the asymptotic error constant. Now, there is one more definition of order of convergence of rate of convergence, which is in terms of error. So let's see what is error. As we know that error in the nth approximation is denoted by xn minus alpha. Here xn is the nth iteration of approximation that we have generated and alpha is the exact root. Then error at the n plus 1th approximation is denoted by xn minus 1 minus alpha. Now, if we have p is the largest positive real number such that error at the n plus 1th approximation is less than or equal to k times error at the nth approximation to the power p, then we say that the given numerical method has a order of convergence p, and here k is known as the asymptotic error constant. Now, if we obtain p is equal to 1, then this we said that convergence is said to be linear. If we have p is equal to 2, then we said convergence is quadratic. Now, so if you want to discuss the order of convergence of bisection method or numerical method, then we would like to obtain the relation connecting error at nth approximation and error at n plus 1th approximation in this way, in like this way here shown, and so that we can make an immediate conclusion about the order of convergence of a given numerical method, means bisection method or Newton-Raphson method. And we can also make some statement about the asymptotic error constant. So let's start our discussion or details of the convergence analysis of bisection method. As we know that we have already discussed this bisection method in lecture 1 and 2. So for detail you can see my lecture 1 and 2. We know that the bisection method generates a sequence of iteration. How it generates? Let's see. It starts with an interval a0 b0 such that it contains the root of the given equation. Then we take the midpoint of this, which is denoted as x1, means it is the midpoint of is the first approximation of the root. Now, it takes the appropriate interval and call it is a1 b1 such that it encloses the root of the given equation. Then we take the midpoint of this and we call it x2 here. Then x2 is the second approximation of the root of the given equation. In this way we generate a sequence of iteration of approximation x1 x2 and so on xn. Now at every step what happens, the interval that encloses the root of the equation is such that its length is half of the length of the interval in the previous step. Means therefore we say that the root of the equation alpha is such that the difference between n plus 1th approximation to alpha in absolute manner is going to be half of the difference between xn minus alpha in absolute value. Or also, as we know what is error analysis, so we can say error at the n plus 1th approximation is half of the error at the nth approximation. Now, from this equation, xn minus 1 mod of xn minus 1 minus alpha divided by xn minus alpha is equal to 1 by 2. This. Now, compare this with our definition of order of convergence. What we have? We have p is equal to 1 and lambda is equal to 1 by 2. As we can see here, power is p, so p is equal to 1 and lambda is equal to 1 by 2. Also, what we have in terms of error analysis, our error at the n plus 1th approximation is half of the error at nth approximation. Come now, compare it with the definition. What we have? K is equal to 1 by 2 and p is equal to 1. Means the given bisection method converges linearly because here p is 1. Or we can say bisection method has linear order of convergence. Or we can say bisection method set order of convergence to be 1. Now, let's work out the details of the convergence analysis of the Newton-Raphson method. Now, let here suppose that alpha be the simple root of the equation fx is equal to 0. Then f of alpha is equal to 0 and f dash alpha will not be equal to 0 because alpha is the simple 0 root of the given equation fx is equal to 0. Now here we assume that f double dash be continuous. Now define the error as epsilon n is equal to xn minus alpha. Here xn is the nth approximation that we have obtained by using Newton-Raphson method and alpha is the exact root of the given equation. Then error at the n plus 1th approximation is given by xn minus 1 minus alpha, where xn plus 1 is the n plus 1th approximation that we have generated by using the Newton-Raphson method. So we start with this error at the n plus 1th approximation. Why? Because we want to generate relationship between error at the n plus 1th approximation and error at the nth approximation. So we start with this. What we have? Error at the n plus 1th approximation is equal to xn minus 1 minus alpha. Now, as we have discussed the Newton-Raphson method in lecture 3 and 4, we know that the formula for Newton-Raphson iteration is given by xn plus 1 is equal to xn minus f of xn divided by f prime of xn, and minus alpha is here. Now, we can write it as xn minus alpha minus f of xn divided by f prime of xn. Now, we know that xn minus alpha is the error at the nth approximation. So, what we have? We have epsilon n plus 1 is equal to epsilon n minus f of xn divided by f prime of xn, which we can write as epsilon n plus 1 is equal to epsilon n f prime of xn minus f of xn divided by f prime of xn. Now, we want to simplify this one, making use of the fact that alpha is the root of the given equation, means f of alpha is 0. Now, we know that from here alpha can be written as xn minus epsilon n. So, let's use that property. F of alpha is equal to 0 means f of xn minus epsilon n is equal to 0. Now expand it by using Taylor method. Then what we have? F of xn minus epsilon n f prime of xn plus epsilon n square divided by 2 f double prime of xi n. Means I am writing the error term in terms of xi n. Here xi n line between xn and alpha. So what we have? We can write f of error in epsilon n f prime of xn minus f of xn is equal to epsilon n square by 2 f double prime of xi n. Now we can see that the left hand side of 2 is same as the numerator of the equation 1. So from equation 1 and 2 we can write epsilon n plus 1 is equal to epsilon n square by 2 f double prime j n divided by f prime of x. So we have a relation between error at n plus 1th approximation and error at nth approximation, as error at n plus 1th approximation is half of the error at nth plus approximation to the power 2 multiplied by f double prime xn divided by f prime of xn. Now, xn is the nth approximation of the root to the desired accuracy. Then we can write error at the n plus 1th approximation is half of the error at the nth approximation to the power 2 multiplied by f double prime alpha divided by f prime alpha, which we can express as error at n plus 1 approximation is k times error at nth approximation to the power 2. So now compare it with the given definition. What we have? P is equal to 2. So Newton-Raphson method has a quadratic convergence, or Newton-Raphson method has second order of convergence, or we can say Newton-Raphson method converges quadratically, and the asymptotic error constant k is given by 1 by 2 of f double prime of alpha divided by f prime alpha. Now if xn is the nth approximation or iteration that we have obtained by using Newton-Raphson method, if xn is the up to the desired degree of accuracy or desired degree of tolerance, then we can write k as half of f double prime xn divided by f prime of xn. Here xn is generated by Newton-Raphson method and it is the nth iteration of approximation. So error analysis clearly shows that Newton-Raphson method has quadratic convergence, and therefore it is much better than the order of convergence of bisection method, which converges linearly. And that's why successive approximation or iteration generated by Newton-Raphson method converges much faster than the successive approximation or iteration generated by the bisection method, as we have already seen this in lecture 1 to 4. Now we will see the difference between bracketing method and open method. As we know, bisection method is also known as bracketed method and Newton-Raphson method is also known as open method. So a graphical description of the fundamental difference between bracketing and method and open method is shown in this figure. Here open method is shown on the left, means Newton-Raphson method for example is shown in the right, and the right is constrained in the right we have shown the bracketing method. Now the root is in the bracketing method is constrained within the interval, and in the open method a formula is used to project iterative between xi and xi plus 1 and can diverge or converge rapidly. Meaning in open method the root can diverge or converge rapidly, as we have seen in lecture 1 to 4 of our last lecture. Now we will see some advantage and disadvantage of bisection method. For the detail of bisection method you can see my lecture 1 and 2. We know from last analysis we know that this method guaranteed to converge. The error bound decreases by half with each iteration. Mean at each iteration length of the interval is half of the length of the interval in the previous step. The bisection method converges very slowly, as we have seen bisection method has a linear convergence, and the bisection method can't detect multiple roots. These are the advantage and disadvantage of bisection method. Now let's discuss some advantage and disadvantage of Newton method or Newton-Raphson method. For the detail of Newton-Raphson method you can see my lecture 3 and 4. The error decreases rapidly with each iteration, and the Newton method is very fast compared with the bisection method, because we have seen Newton-Raphson method has second order of convergence and bisection method has linear order of convergence. Unfortunately, if we made a initial approximation not good enough, means if our initial approximation is not good enough, then the method may diverge or the method may fail. So the initial approximation and the choice of x naught is very important in Newton-Raphson method or open method. Each iteration of Newton method requires two function evaluation, while the bisection method requires only one function evaluation. These are the advantages and disadvantages of Newton-Raphson method. Now a good strategy for avoiding failure to converge would be use the bisection method for a few steps to give an initial estimate and make sure that the sequence of guessing is going in the right direction, followed by Newton method, which should converge very fast at this point. Thus, in this lecture, we have seen the convergence analysis and error analysis of Newton-Raphson method and bisection method. That's all for today's lecture, and with this lecture, our unit 4, the solution of algebraic and transcendental equation, is also completed. That's all for today. Thank you.